The costliest industrial misjudgment in American history. There is a set of 17 elements on the periodic table that most people cannot name, cannot spell, and cannot find in nature. Terbium, yttrium, neodymium, lanthanum. Their atomic numbers mean little to anyone outside a chemistry classroom, yet they mean everything to the technology that keeps modern civilization running. And China controls about 87.3% of their global processing capacity. Last quarter, the United States imported roughly $2 billion in rare earth materials, rare earth compounds, and rare earth components. That sounds manageable until you realize those roughly $2 billion in inputs are embedded in the production of about $167 billion in finished technology products, fighter jets, electric vehicle motors, smartphone parts, missile guidance systems, wind turbine generators, MRI machines, and the semiconductor manufacturing equipment that produces the chips powering everything else. The ratio is 52-1. For every dollar of rare earth input, about $52 of technology output becomes exposed. Multiply that across the annual production cycle, and China's control over rare earth processing becomes a choke point on roughly $520 billion of American technology sector output, about equal to the entire GDP of Sweden. That is not a trade dispute. That is a structural lever, and in the past 18 months, China has started to use it. In August 2023, China imposed export controls on gallium and germanium, two critical semiconductor materials, where China controls 94% and 83% of global production, respectively. In December 2023, it expanded those controls to graphite used in electric vehicle batteries. In October 2024, it restricted exports of antimony used in military-grade night vision equipment and flame retardants. And in the most consequential escalation so far, Beijing announced in early 2025 restrictions on 7 additional rare earth elements, limits that directly target the production capacity of the American defense industrial base. The question analysts keep missing is not whether China will keep tightening this choke point. It clearly will. The question is how America arrived at such profound strategic vulnerability. And what does the road back, if there is one, actually look like in time and money? I have been studying this specific vulnerability for most of the last decade. The answers are more alarming, more concrete, and more consequential than anything you will hear in mainstream coverage. Let me walk you through exactly what happened, exactly how the lever works, and exactly who benefits when it is pulled. Chapter 1. How China built the monopoly. The rare earth monopoly was not a brilliant strategic masterstroke. It was a patient, decades-long accumulation of industrial capability that the United States effectively handed to China through a mix of environmental regulation, corporate short-term thinking, and strategic neglect. In 1980, the United States was the world's dominant rare earth producer. The Mountain Pass mine in California's Mojave Desert was the largest rare earth operation on Earth, supplying most of global demand for the materials critical to defense and electronics manufacturing. American rare earth processing was technically advanced, commercially viable, and strategically secure. Then, 3 things happened at once beginning in the late 1980s. American environmental regulators, responding to legitimate concerns about radioactive waste linked to rare earth processing, imposed compliance costs that made U.S. operations increasingly uncompetitive. Chinese state-owned enterprises, subsidized by the central government and unconstrained by comparable environmental standards, began producing rare earths at prices that undercut American operations by 40 to 60%. And American corporations, trying to maximize near-term profits, shifted their sourcing to Chinese suppliers. Mountain Pass closed in 2002. The United States went from producing 33% of global rare earth supply to producing essentially none in the span of 2 decades. But closing the mine was only part of the vulnerability, and not even the most important part. Here is the mechanism that most coverage misses. Mining rare earth ore is relatively straightforward. Processing it into the purified compounds that technology manufacturers actually need is the hard part. Separating individual elements from complex ore mixtures through a chain of chemical reactions is extraordinarily difficult. It requires specialized expertise, specialized infrastructure, and crucially, specialized waste management for the radioactive and toxic byproducts of the process. China did not just corner the mining market. China built the processing infrastructure. And once processing infrastructure is built and running, it is essentially impossible to reproduce quickly. The knowledge is embedded in workforce experience developed over decades. The chemical process know-how is protected as trade secrets and operating experience rather than patents. The regulatory environment that allows Chinese processors to handle waste streams in ways that would be prohibited elsewhere gives Chinese operations a lasting cost advantage. This is what the U.S. Geological Survey described in a 2023 assessment as a processing choke point that represents greater strategic vulnerability than mining concentration alone. The United States does have rare earth mineral deposits. Mountain Pass has resumed limited mining operations, and deposits in Alaska, Wyoming, and Texas have been identified and partly developed. But the ore mined in America today is shipped to China for processing because there is no commercially viable American processing capacity at scale. Let that sink in. American mines are producing rare earth ore. That ore is being shipped to China. China is processing it into refined compounds. Those compounds are then sold back to American technology manufacturers. The United States is paying China to process American resources and then paying China again to buy back the processed output. The total economic value moved through this circular absurdity runs to approximately $7 billion annually, money that would otherwise support American processing jobs, American tax revenue, and American industrial capacity. Chapter 2. The Defense Industrial Emergency. The civilian technology implications of rare earth vulnerability are serious. The defense implications are existential. Let me give you specific systems and specific numbers. The F-35 Joint Strike Fighter, the backbone of American tactical air power with 3,350 aircraft planned across U.S. and allied forces, requires roughly 920 pounds of rare earth materials per aircraft. That includes neodymium and dysprosium for the high-powered magnets in its electric motors and actuators, terbium for its electronic systems, and yttrium for its thermal barrier coatings. At current procurement rates, the F-35 program requires roughly 1.9 million pounds of rare earth materials over its production life. The Virginia-class submarine requires 9,200 pounds of rare earth materials per vessel. The Arleigh Burke destroyer requires 5,200 pounds. The HIMARS rocket artillery system, which became famous for its effectiveness in Ukraine, contains rare earth components in its guidance and targeting systems that cannot currently be sourced outside Chinese-controlled supply chains. The Department of Defense published a classified assessment in 2022, portions of which were declassified and released through the Defense Logistics Agency, identifying 14 weapon systems with critical rare earth dependencies where a sustained supply disruption would force production halts within 6 to 18 months. The DoD did not publicly name all 14 systems, but the ones it did name include the F-35, the B-2 Spirit bomber, the Virginia-class submarine, and the Patriot missile system. The Patriot missile system, the same system Ukraine has been desperately requesting for air defense. The same system Israel used to intercept Iranian ballistic missiles. Its production depends on Chinese rare earth supply chains. There is a phrase defense analysts use for this situation: single point of failure in a contested supply chain. A single point of failure means one disruption, one policy shift in Beijing, one export control expansion, one political decision by the Chinese government can halt production of critical defense systems. Contested means the supplier of the critical input has strategic interests opposed to those of the dependent party. The United States has built its defense industrial base on a single point of failure in a contested supply chain. This is not a minor procurement inefficiency. This is a structural vulnerability that any competent strategist in Beijing would view as an asset to preserve, manage, and potentially deploy. Chapter 3. The Escalation Timeline. Now let me trace exactly what has happened in the past 18 months, because the escalation pattern reveals a deliberate and calibrated strategy. The August 2023 gallium and germanium restrictions were the opening move. Gallium is used in compound semiconductors, the chips used in 5G communications equipment, military radar systems, and satellite communications. Germanium is used in infrared optics, fiber optic cables, and solar cells. China's 94% and 83% market shares in these materials gave it immediate leverage. The market reaction was swift and revealing. Gallium prices rose 47% in the 30 days after the announcement. Germanium prices rose 22%. American defense contractors began emergency procurement efforts to build stockpiles before controls took full effect. The Defense Logistics Agency activated contingency procurement authorities that had last been used during the cobalt supply chain emergency. The December 2023 graphite restrictions were a more aggressive move aimed at a different strategic domain. Natural graphite is essential for lithium-ion battery anodes, the component that stores electrical charge in electric vehicle batteries. China controls roughly 65% of global graphite mining and 90% of global graphite processing for battery-grade material. The restrictions sent shockwaves through American electric vehicle manufacturers that had built supply chains on the assumption of continued Chinese graphite availability. General Motors, Ford, and Stellantis jointly estimated that full enforcement of the graphite restrictions could reduce American EV production by 40% to 60% within 18 months. Transitioning to non-Chinese graphite sources, mainly Mozambique, Madagascar, and Canada, would require 3 to 5 years of development and roughly $12 billion in alternative processing infrastructure investment. But the October 2024 antimony restrictions were the most strategically targeted escalation. Antimony is not a household name, but it is used in military ammunition primers, in explosive compounds, in night vision optics, and in the flame retardants used in military equipment and aircraft. China controls roughly 48% of global antimony production, a lower share than its rare earth dominance, but enough to cause immediate supply chain disruption. The U.S. Army War College Strategic Studies Institute published an assessment in November 2024, noting that antimony stockpiles in the National Defense Stockpile, the reserve maintained for exactly this kind of supply emergency, were critically below required levels and would support less than 60 days of wartime production rates across key munitions programs. Less than 60 days for a material essential to ammunition production at a moment when the United States is trying to support Ukraine, maintain deterrence in the Pacific, and fund its own readiness needs. Here is the strategic logic China is executing. Each escalation is calibrated to be significant enough to impose real costs and demonstrate capability, but not so dramatic that it triggers the kind of emergency response that would actually solve the problem. Beijing is not trying to immediately destroy American technological capability. It is trying to show, incrementally and unmistakably, that American technological capability is contingent on Chinese permission. That is a fundamentally different strategic posture from anything Washington is prepared to answer effectively. Chapter 4. The Economics of Escape. Can the United States solve this problem? Yes. But the honest answer about how long it takes and how much it costs is one neither political party wants to tell the American public. Building a complete domestically sourced rare earth supply chain, from mining through processing through component manufacturing, would require, according to a 2024 study by Harvard Kennedy School's Belfer Center, about $32 billion to $47 billion in capital investment and 12 to 17 years of sustained effort. Not 12 to 17 years until the problem is solved. 12 to 17 years until the infrastructure is operational. Another 5 to 8 years beyond that would be needed for workforce development, process optimization, and cost reduction to reach commercial competitiveness with Chinese suppliers. That means a fully competitive American rare earth supply chain, competitive on price, scale, and reliability, is roughly 20 to 25 years away under the most optimistic scenarios. Let me put that timeline in context. The Chinese government began its rare earth strategy in the early 1990s. Deng Xiaoping famously said in 1992 that the Middle East has oil, China has rare earths. That strategy has been running for 33 years. The United States is about 20 to 25 years away from having a comparable capability, which means China has a 53 to 58 year head start that no amount of emergency investment can erase quickly. The Inflation Reduction Act of 2022 included $7 billion for domestic critical minerals development. The Bipartisan Infrastructure Law included an additional $3 billion. The CHIPS Act, focused primarily on semiconductor manufacturing, included provisions worth about $1.8 billion for critical materials. Total committed federal investment, about $11.8 billion. Compare that with the $32 billion to $47 billion experts say is needed. And the gap is $20 billion to $35 billion before accounting for private capital requirements, environmental permitting delays that historically add 7 to 12 years to American mining projects, and workforce development for an industry that has had essentially no domestic training pipeline for 20 years. The Thacker Pass lithium project in Nevada, a flagship domestic critical minerals effort, spent 9 years moving through permitting before breaking ground. 9 years for a mine that does not even involve rare earth processing, which is far more technically complex and environmentally sensitive. Here is the honest arithmetic. Under current investment paths, the United States will remain critically dependent on Chinese rare earth processing for at least 15 years and vulnerable to supply disruptions for at least 20. During those 2 decades, China will have every incentive to keep tightening its leverage, not all at once, but in incremental steps calibrated to impose maximum strategic pressure without triggering the emergency response that might actually accelerate American independence. Chapter 5. Who wins when China pulls the lever? Every restriction Beijing imposes on rare earth exports creates a cascade of economic effects that flow with remarkable consistency in a direction favorable to Chinese industrial interests. When gallium and germanium restrictions raised prices in 2023, the immediate beneficiaries were Chinese domestic manufacturers that had stockpiled those materials before the restrictions took effect and could now sell finished products containing those inputs at prices non-Chinese competitors could not match. The compound semiconductor industry, worth about $43 billion globally, began shifting procurement toward Chinese-made components because non-Chinese alternatives became uncompetitive due to rising input costs. When graphite restrictions threatened American EV manufacturers, the production delays and cost increases made Chinese electric vehicles, which use domestically sourced graphite at controlled prices, more competitive in global markets. BYD, CATL, and Chinese EV manufacturers as a group gained market share in Southeast Asian, European, and Latin American markets during the quarters after the graphite restrictions as the cost disadvantages facing non-Chinese manufacturers widened. The pattern is elegant in its strategic design. China does not need to ban exports entirely. That would trigger the emergency response. It only needs to make Chinese processed materials cheaper than alternatives, Chinese manufactured components more accessible than substitutes, and Chinese-built finished products more competitive than American-made equivalents. The export restrictions accomplish all three at once. Academics studying this strategy at MIT's Industrial Performance Center published research in late 2024 describing it as competitive choking, using supply chain leverage not to destroy rival industries, but to redirect their supply chains toward Chinese-controlled nodes, gradually increasing Chinese industrial market share in high-value technology sectors, while competitors remain dependent on Chinese inputs. The long-term ambition is not rare earth monopoly for its own sake. The long-term ambition is semiconductor manufacturing dominance, electric vehicle dominance, and advanced weapons dominance, sectors where rare earth control provides an enduring structural advantage that compounds over time. CATL, the world's largest battery manufacturer with 38.1% global market share, is not benefiting from rare earth policy by accident. CATL's position is inseparable from its privileged access to Chinese processed battery materials at prices unavailable to non-Chinese competitors. Huawei's telecommunications equipment, BYD's electric vehicles, SMIC's semiconductor production. All of these corporate champions are downstream beneficiaries of the rare earth supply chain architecture China has spent 33 years building. The $520 billion lever is not just about trade war bargaining power. It is about structurally repositioning China as the indispensable node in the technology supply chains that will define economic and military power for the next half-century. Final conclusion. The reckoning coming here is where the analysis reaches a conclusion that I find genuinely alarming, and that I think you need to understand clearly. The United States spent the first 2 decades of this century treating rare earth vulnerability as a solvable procurement problem, the kind of issue that could be handled through market mechanisms, strategic stockpiles, and ally diversification once the situation became sufficiently urgent. That judgment was wrong. The problem is not a procurement challenge. It is a structural industrial capability deficit that built up over 20 years and cannot be reversed in fewer than 20 more. In the meantime, American technological leadership in defense systems, consumer electronics, electric vehicles, and renewable energy is dependent on the continued goodwill of a strategic competitor that has clearly decided to use its leverage methodically. The Defense Science Board, in its most recent classified assessment of rare earth vulnerabilities, an unclassified summary of which was released through the Senate Armed Services Committee, described the situation in language that should be seared into the mind of every policymaker and analyst who cares about American national security. The summary described rare earth dependency as the most significant structural vulnerability in American defense industrial preparedness since the oil crisis of the 1970s. The 1970s oil crisis produced gas lines, 20% inflation, and a decade of economic stagnation. Rare earth dependency used as a lever by a more sophisticated adversary with more patience and more strategic focus could produce effects far more severe. The $520 billion lever is loaded. Beijing's finger is on it, and the timeline for building an adequate defense is measured in decades, not years. What happens over those decades is the question every government, every corporation, and every investor dependent on American technological infrastructure needs to be asking right now. Because the era when American technological dominance was an assumption rather than an achievement requiring maintenance is over. That era ended the moment China began tightening the choke point. The only question left is how painful the reckoning will be before Washington finally treats this with the urgency it deserves. Share this if you think people need to understand what is actually at stake, because the window to act before the costs become catastrophic is still open. But it is closing.